1H.L1.4. Rubbing your hands together warms them by converting work into thermal energy. Assume that rubbing your hands back and forth involved a total distance of 7.5 centimeters with an average frictional force of 40 newtons. When it's cold outside, assume your hands are losing 25 joules of heat every 2 seconds. Part A asks us, what rate do you need to rub your hands back and forth for them not to get colder? So the problem's told us that this distance is 0.075 meters, 7.5 centimeters, and they've also told us that the force of kinetic friction is about 40 newtons on average. And our main formula here is change in energy thermal equals work, so this is the work being done on or by the system, plus Q, the heat entering or leaving the system. The problem says that when it's cold outside, your hands are losing 25 joules of heat every 2 seconds. So we can write that Q equals negative 25 joules per 2 seconds. And they told us in part A that we need to calculate for when the change in thermal energy is 0. I'm going to write that as 0 over 2 seconds. Because you want to lose 0 joules of energy over the 2 seconds. So that would mean for the change in thermal energy to be 0, W has to be 25 joules over 2 seconds. Basically, you have to rub your hands together enough times so that you produce 25 joules over the 2 seconds. So the change in energy by your hands is going to equal the force of kinetic friction times the change in distance. So for one hand rub, the change in distance is 0.075 meters. So for one hand rub, that's going to be 40 times 0.075, which equals 3 joules. So every time you rub your hands once, you're producing 3 joules. So we said before that work is going to equal 25 joules in 2 seconds, which means that it's 12.5 joules in 1 second. So we want to produce 12.5 joules. How many hand rubs does that take? So 12.5 divided by 3 joules per hand rub equals 4.167 rubs per 1 second. So that's the answer to part A. So the next part of the problem is asking us to use order of magnitude and known quantities sense making to see if this answer is reasonable. So I looked it up, and the fastest clapper in the world is able to do 804 claps in 60 seconds, in 1 minute. So per second, that equals 13.4 claps in 1 second. So that is one order of magnitude greater than 4.167. So for a reasonable person, 4.167 rubs per second does seem reasonable. Thanks for watching.